the unit square in the topic Matrix of Transformation. So, welcome to the third lesson of our topic Matrices and Transformation. In this topic, we are going to deal with the unit square. So, what is a unit square? A unit square is a one unit square, simply as that. We have a figure here which is a square. So we can say this is 1 unit and this is 1 unit. So that is what we call a unit square. So it could be 1 centimeter, 1 meter. That is still a unit square. So we are going to present the unit square on the Cartesian plane and see how we use it in this topic to determine the matrix of transformation. We are going to use this graph to plot our units square. So we will take that as the origin. Let's take this is our y-axis and this is our x-axis. So we can have this is 1 and this is 2 along the x-axis. This is 1 and this is 2. So we have defined a unit square as a square that has 1 unit in dimension. So let's take that is for along the y-axis, here that is 1 unit, along the x-axis that is 1 unit, and here we have another point. So those 4 points plus the origin forms the unit square. So this is our unit square. We are going to name the vertices of our square. So this we are going to give it I, capital I. This we are going to name it J, and this we are going to name it K. So we have the vertices, and of course we have the origin. So we have O, which is the origin. The coordinates of the origin obvious is 0, 0. Then we have I. The coordinates of I is 1, 0, 1, 0. And the coordinates of J are 0, 1. And the coordinates of K are 1, 1. So this is 1, 0. This is 1, 1. This is 0, 1. And of course we have the origin. So those are the coordinates of a unit square. So we are saying that the vertices of I, which is 1, 0, and J, when written both in column form, makes an identity matrix. We utilize the properties of an identity matrix to help us identify the matrix of transformation. So here we have, this is our I. So I can be written as 1, 0 in column form, and the J can be written as 0, 1. We put the bracket. So you note here that this is an identity matrix, whereby this is our I and this is our J. So in conclusion, the unit square help us to easily identify the transformation represented by a given matrix. It also helps us to obtain easily a matrix for a given transformation. Why are we saying easily? Because in our earlier lesson, we saw that for us to identify the matrix of transformation, we had to get a triangle, pre-multiply the image, the matrix and the image that we had to get the object. If you are given the image and the object, you have to do some multiplication for you to be able to identify the matrix of transformation. So we are going to see that clearly in our following example. So our example 1. Find the image of I and J under the transformation matrix 3, 0, 0, 1. As you remember earlier, for us to get the image, we pre-multiply the transformation matrix by the matrix that is formed from the coordinates of our object. So if we take, this is our I, the coordinates of I are 1, 0, and the coordinates of j are 0, 1. So from there, then we can form the matrix of I and j. So we have, this is 1, 0, and 0, 1. So this is I, and this is our j. Now, this is now the matrix formed by the object, that is of the I and j, which are part of our unit square. So for us to get the image of the unit square using this transformation matrix, we write, then we have our transformation matrix, which is 3, 0, and we have 0, 1. We multiply by the matrix of our object, which is 1, 0, and 0, 1. When you multiply that, you note that this is an identity matrix, and whenever we multiply anything by identity matrix, it is like multiplying by 1. It doesn't change. However, let's multiply and see what we get. 3 times 1 is 3, 0 times 0 is 0, so 3 plus 0, we end up with 3. Then 3 times 0 is 0, 0 times 1 is 0, 0 plus 0 is 0, 0 times 1 is 0, 1 times 0 is 0, 0 plus 0 is 0, 0 times 0 is 0, 1 times 1 is 1, so 0 plus 1 is 1. So you note here that our transformation matrix has not changed. Actually, we can say that our image, this is our image of this is I prime and j prime are the same as the transformation matrix. Now, from what we have seen, the transformation matrix actually forms the image. So we can conclude, since I, 1, 0, and j forms an identity matrix, that is 1, 0, 0, 1, the coordinates of the image are formed from the transformation matrix. Generally, the way I take it is that what has happened to the unit square will enable us to get the transformation matrix that has occurred. The following example is going to demonstrate very well how the unit square help us to get the transformation matrix. In our example 2, describe the transformation represented by 0, 1, minus 1, 0. Now, we know, we have learned that the coordinates of I are 1, 0, and the coordinates of j are 0, 1. They form an identity matrix, which is 1, 0, 0, 1. So this is, we are going to use the unit square to help us identify the transformation represented by this matrix. So this is our object. So we pre-multiply with the transformation matrix, which is 0, 1, minus 1, 0, and our object is 1, 0, 0, 1, which is an identity matrix. That means it doesn't change. We will still remain with our matrix here, minus 1, because it is like multiplying by 1. So what this means, that since we are saying this is our I and this is our j, the image of I is that 0, 1, and the image of j is that. So we can make a sketch here and say what has happened to our unit square. So this is just a sketch, so don't worry about the straightness of the line. So this is x. So we take one unit here, that is 1, that is 1. So this is j and this is I. Now if we make the unit square, that is the unit no, that's not good. So this is, we come down here. This is going to be our k. Remember, our coordinates of k are 1 and 1. Now, I has been transformed. Our new I is coordinates 0, minus 1. So it is x is 0 and this is minus 1. So this is where we have our I, the image of I. The j prime coordinates are 1, 0. So it means this is our new j. Now if we plot this square, unit square, it will be like that. It's just a sketch. So this is the object and this is the image. So we can clearly see that the transformation here is a reflection through the line y-axis, or y is equals to 0. So we conclude that the matrix represents transformation. So it is a reflection through x-axis or y is equals to 0. So you can see very easily we have used our unit square to identify the matrix represented by this, the transformation represented by this matrix. So let's do another example. In our example 3, describe a transformation represented by matrix 0, minus 2, 2, 0. So we multiply our unit square with this matrix. So this means we have 0, we have minus 2, we have 2, we have 0. The units, our unit square, we have 1, 0, 0, 1. So remember, this is our I and this is our j. When you multiply that, you'll be able to get the same matrix as this one, because this is an identity matrix. So you have 0, minus 2, and 2, 0. So that is our image. So this means that this is the image of I and this is the image of j. From there, so we have our I, the coordinates are 1, 0. Our j, the coordinates are 0, 1. And our image, we have our I prime, we have the coordinates 0, 2. This is what we have obtained after multiplying the unit square. And we have a j, which will be minus 2, 0. So let's make a sketch of that and see what has happened to the unit square, which is going to give us the transformation represented by this matrix. Okay, this is the sketch I have. You can just use your hand to make that sketch. So this is where we have our I, and this is where we have our j. This is our k. The new image of j, of I, is 0, 2. So x is 0 and 2. So here is where we have the image of I. J is minus 2, 0. So this is where we have j prime, the image of j. Of course, now this is our image of k. If you observe this, you find that since this is our object, this is our image, what has happened to the unit square? It has been enlarged. First of all, if you reflect the unit square through the line y-axis, you get the first figure. Then you enlarge it, enlargement scale factor 2, you will be able to get this image. So we can conclude that the transformation is a reflection. We can say the matrix, this matrix here, represent a reflection in the line x is equals to 0, or y-axis followed by enlargement enlargement scale factor is 2. So that is what this matrix represent. So from you can clearly see that the unit square is very important in determining the unit the transformation represented by a given matrix. If we are not to use the unit square, then we had a triangle with transformation matrix, then draw the figure, and then the transformation represented by that matrix. But you see here now, with our unit square, we are able to identify the transformation represented by the matrix very easily. Let's do another example. In our example 4, we are required to describe the transformation represented by our matrix, which is 0 minus 2. Then we have minus 2, 0. What we are going to do is to pre-multiply this with our unit square matrix. So we have 0, we have minus 2, we have minus 2, and we have 0. So when you multiply this 1, 0, 0, 1, you will get the same matrix. So it is 0, minus 2, minus 2, 0. I hope you understand. So we are multiplying 0 times 1 is 0, minus 2 times 0 is 0. So 0 plus 0 is get 0. And then 0 times 0 is 0. Minus 2 times 1 is minus 2. So 0 plus minus 2 gives us minus 2. Minus 2 times 1 is minus 2. 0 times 0 is 0. So minus 2 plus 0 gives us minus 2. Minus 2 times 0 is 0. 0 times 1 is 0. So when you add 0 plus 0, it gives you that. What this implies is this is our I and this is our J. So this is the image of I and this is the image of J. So we can clearly write I, that is I, we have 1, 0, and our J, it is 0, 1. The image, that is our I, is 0, minus 2, and our J prime, or image of J, is minus 2, 0. So we are going to sketch this and see what happens to our unit square, and that is going to help us describe the transformation represented by that matrix. So this is my sketch. This is where I have 1. This is 1. This is where we have minus 1, minus 2. This is 0. This is minus 1. And here we have minus 2. So this is our object and this is our image. We can say that what has happened. Okay, this is where we have our I. This is where we have our K. This is where we have our J. The image of I is 0 minus 2. So this is where we have the image of I. This is where we have our J's, minus 2, 0. So this is where we have J prime. Of course, here we have K, the image of K. If we look at this, what has happened to the unit square to give us this image? It has been enlarged, but on the opposite side of the center of origin. This is the center of origin at 0, 0. So when an object is reflected in the opposite side of the center of enlargement, we say that the enlargement factor is minus. The enlargement factor is minus, and if you look at from 0 to I, it is half this. So the distance from the origin to I prime is twice the distance from the origin to the I. So it is enlargement. Enlargement scale factor is equals to -2 because it is on the opposite side of the center of the enlargement. Center of enlargement is actually, we can just say center of enlargement is equals to 0, 0, 0, 0. That is, or we can refer to it as origin. So I think we have seen that it is very easy for using the unit square to give the transformation represented by the matrix. Let's do our final example, and then that will be the end of our lesson. In our last example, find the matrix of refraction in the line y is equals to x. So the line y is equals to x. We can make a sketch of that so that we determine what is the matrix of transformation. This is the sketch. This is a sketch that I have. This we can label it is 1. This is -1. This is 0. This is 1. And this is -1. Now, because our transformation is a reflection in the line y is equals to x, this is where we can put our I. This is our k. That is our j. So if you reflect I through the line, this, of course, this is the line y is equals to x. If you reflect this I, the image of I will be here. The image of j will be there. Therefore, the coordinates of I will be 0, -1. The coordinates of, that is I prime. The coordinates of j prime are -1, 0, -1, 0. And with these two forms a matrix, that is the matrix 0, -1, and -1, 0. And we can now say this is our I prime and that is our j prime. And remember, we are saying the matrix formed by the image of our unit circle. This is our image, this is our object, forms the matrix of transformation. So the matrix representing the reflection through the line y is equals to x is this matrix, which is now 0, -1, -1, 0. So that brings us to the end of our lesson. I hope you will be able to get more examples to help you understand in any area that you have not understood. If you have any question, you can always pass it to me. I will be able to assist you. So you are welcome to our third lesson and many more examples that I will be posting. Thank you for listening.